something in sort of pulling together one location where entrepreneurs and innovators can be together, and this is a great facility, great turnout, and I appreciate it. So I'm going to spend my time with you talking about 3D printing and innovation and how there's a lot of hype and reality in the market, and let's spend a little bit of time sort of separating the two, giving you sort of some context for what 3D printing is and thinking about what the opportunities might be. So I'm sure you saw yesterday that President Obama was in town, announced a new manufacturing innovation institute at NC State. To put some context in, this announcement was the second innovation institute which is part of a planned program of innovation institutes in manufacturing, the first of which was around additive manufacturing or 3D printing in Youngstown, Ohio. Manufacturing is important to the national government, it's important to the state of North Carolina, it's important to me. It represents 12% of our GDP, and it's an area where I think you truly can see a lot of innovation in manufacturing, and additive manufacturing or 3D printing is one of those areas. So before we actually start the presentation, maybe I want to sort of ask a couple questions. And the first one is, before you all got into this room, and I don't mean online, how many of you had ever seen a 3D printed part before? Okay, so that's actually a pretty good group of people. How many had seen an actual 3D printer before? Okay, so probably about half. How many of you, by a show of hands, believes that 3D printing is 5 years old or younger? How many believe it's 10 years old or younger? Okay, how about 30 years old or younger? Okay, 3D printing is now 30 plus years old. It was actually founded by, by one of the co-founders of 3D Systems. And I think that's important context because you need to realize that 3D printing isn't new. What's new is the application of the technology and how that can sort of unlock or be new opportunities and new creative ways of using the technology. So in my time, I'm going to talk to you about 3D printing, what it is. What is additive manufacturing? Well, it's the same thing. Additive manufacturing is the technical term of art. 3D printing is more of the vernacular that people use. I want to paint the picture for what the ecosystem is, because 3D printing just does not exist by itself. It exists as part of a pipeline. You need to have something to print. And the reason why 3D printing has started to accelerate in the market is because that entire pipeline has changed, and we're going to talk about some of those drivers. How big's the market? Some key trends, takeaways, and then hopefully, if we have time at the end of my presentation, some questions, and if not, we'll do it during the get-together afterwards. My goal here is leave you guys excited. You know, additive manufacturing, 3D printing, investment in manufacturing innovation is sexy stuff. It is exciting. It's important for our national competitiveness. Personally, I'm excited by it, and commercially, I've had some good success with it. And I hope when you guys leave, you have a sense of what some of these new technologies can do for all of you. Don't try and read the chart. This is from Wikipedia. What that chart shows is what are the various types of additive manufacturing technologies. I'd encourage you to go to that as a resource because it will help you understand what some of those 3D printing technologies are, and I think our good friends from GE are going to sort of actually show some of these technologies. I'm going to walk you through some of the key ones to just sort of frame the rest of our talk. The first type of 3D printing technology that's sort of in most of the low-end consumer printers is this stuff called FDM, Fused Deposition Modeling. Big word, fancy word. What does it really mean, or what does it look like? Think toothpaste tube, you squeeze the tube, stuff comes out of the tube. At a very simplistic level, that's what an FDM printer is. It takes a spool of plastic, it heats it up, it melts, and a nozzle moves back and forth across a build platform, and as the plastic hardens, that makes the object. It's the foundational technology for most of the consumer-based printers out there, but it's also the foundational technology for a lot of high-end 3D printers from Stratasys. Sort of next technology you'll hear about is stereolithography, resin-based printing. That's a printing technology where you have a vat of resin, think a polymer, that once you strike it with a laser or some other kinds of light, it hardens. And so the way stereolithography or SLA-based printing works is a laser or some other type of light is selectively imaged to the vat of resin. The resin hardens, and then the build platform drops down, and more resin is added, et cetera, et cetera. I think you guys have some videos that might actually show some of the stuff. It tends to have better surface finish, better material qualities, more expensive. The next range of consumer printers are going to be resin-based printers. And we'll talk about that a little later and what that means for the market. One big takeaway from this slide is every manufacturer of 3D printing uses different acronyms. So Wikipedia might call it granular electron beam melting. You might go to one vendor who has an entirely different acronym for it, and they do it for marketing purposes. So just think more about the technology and not about the names so much. Sort of next, we'll concentrate on this one. The next type of printer is a 3D print head will spray a binder, like a glue. A little roller will come across and push some powder, and then the build platform will drop, and the head will come across and spray more resin. So you're building up basically by layers of glue in the powder. And then a sort of final technology, which is really mostly used in the metal market, is selective laser sintering. I'm not going to spend a lot of time talking about that. From a consumer perspective, these two printer types are the printer types that you're going to see in consumer-based printing. So how are they used? Well, the first main area where 3D printers are used and have been used is in concept modeling. Concept modeling is, you're a designer, you want to share an idea with people. You want to be able to give them something tangible to hold. So you create in a 3D printer. The old way would have been you would have had to machine something or do a very manual process to produce this concept model. With 3D printing, you can actually print a non-structural, so not a very strong object, and it might not even have very good surface finish, but it serves the purpose of being able to hand something around a room and say, look at this idea, how does it feel, how does it look? A lot of times people will sand it, they'll print it, they'll paint it, but it's for conceptualization. The second main area for 3D printing is functional prototyping, which is using stronger materials, better printers to actually create sometimes functional parts. These are typically not mass-produced, but they're used to show form, fit, or function. And an example would be, it might be a bad one, you probably have a hard time seeing it, but in an aerospace production line, you need to be able to show somebody how to route a given cable. And there's a part that needs to fit in that gap. To machine it would cost a lot of money. To buy it would cost a lot of money. To actually take one out of inventory and put it in would cost a lot of money, but you still need to be able to provide that person a visual reference to know how to put the part in. You can use 3D printing to actually provide a guide for that person for assembly. The next main area is manufacturing tooling. A lot of 3D printed output is actually used as an input for another manufacturing process. So an example here is this company in Germany called Voxeljet. They produce molds which are used as part of a traditional casting process. Now, you can create molds without 3D printers, but 3D printers provide an exceptionally fast way of creating molds as the input for an existing manufacturing process. And the same thing here with this example from Envision Tech, which is a jeweler who creates a little ring design. They mount it, they pour plaster to make the negative, and then use that as part of a traditional casting process. It's important to recognize that today, 80% or more of 3D printers are not used for direct part production. Only about 20% of 3D printers actually output something which is used as a part which is part of a finished product. And there's a lot of reasons for that. Material quality, cost. You typically find direct part production restricted today to very high-end 3D printers and metal-based printers. And to give an example of cost, you can buy a 3D printer which would work quite effectively in this range for $5,000 from a professional perspective. In this range, you might have to spend $750,000 for a 3D printer. And so it tends to be restricted to high-value types of highly engineered products. So I won't spend a lot of time on each of these sort of verticals, but except to say this is the kind of the main penetration for where 3D printers are used. As you might expect, aerospace and automotive and high-value manufacturing are where a lot of 3D printers have traditionally been used. In aerospace, it's for custom parts. For automotive, a lot of it's for conceptual design. The area that's really growing, and we're going to talk about, is the maker's market and the consumer market, which is all the noise you're hearing in the market today about 3D printing is because of the growth here and in education. One of the takeaways you need to take from today is that 3D printers have been used for high-value manufacturing for 30 years. They will continue to add value in high-value manufacturing. There's lots of innovation to be made in high-value manufacturing. Prices have come down, so manufacturers can use them more frequently. A lot of the current marketing noise is around the makers movement. So let's talk about that 3D printing ecosystem. So if you've got a 3D printer and you want to print something, where do you get it from? Well, it's just like a 2D printer at home. If you don't have content, you have the best printer in the world. It doesn't really matter. So 3D content comes from a variety of sources. It comes from modeling applications, like that. It comes from using high-end scanners to scan something to print it, to make a digital copy. It comes from mechanical applications. And this is the chart we used to use at Geomagic to sort of explain that process, which is you can create it from a CAD application, you can create it from photos, you have to have software to manipulate it, and then it gets printed out the other end or manufactured. The change in the 3D printing market is driven not only by advances in 3D printing, but the fact that this whole side of the market has changed too. Because if you don't have content to print, having the best printers in the world won't help you very much. And I want to stress that 3D printing always has to be thought of in an ecosystem. And why is that ecosystem important? Hewlett-Packard, currently not in the printing market, okay, in the 3D printing market. But I think the parallel is exactly the same. Today, that's what they sell. This is what 3D printer companies sell. Hewlett-Packard has 9,000 patents on imaging and printing. 4,000 of them are around consumables. How do you get consumables? You can get consumables because people have stuff to print. The 3D printing market is going to be shaped by finding an easy pathway for consumers and for others to drive more throughput through printers so they can ultimately do what? Sell more consumables. That's also one of the drivers for why prices have come down in the market, because finally with enough of these enabling technologies, the 3D printing companies realize that we can sell printers at a cheap enough cost and subsidize it based on the money we think we're going to make on consumables. And that's like the razor blade model, that's like cell phones. It's a huge shift in the market from a dynamics perspective. So how big is the market? These charts are from a good friend of mine, Terry Wohlers. Terry Wohlers is an industry analyst who's been tracking the additive manufacturing market for probably 30 years or so. It's a surprisingly small market, relatively speaking. It's today about $2 billion in revenue, and it's expected to grow 20% plus per year over the next 5 to 7 years. What's really interesting is, if you look at professional printers, the type of printers that make this stuff, 10,000 units next year. Okay? Not, I mean, when you're at $100,000 or $200,000 a pop, that's a lot of money, but it's not 500,000 units. The consumer market has grown from basically nothing in 2008 to next year. The projection is that 100,000 printers will be sold in the consumer market, 10 to 1. And why in the world is that possible? How can that change? What happened to unlock that market opportunity? This chart I looked at, because I asked myself that question, why did it happen? If you take a look at the term additive manufacturing, we talked about that, the sort of technical term for 3D printing. This is a Google Trends chart. This chart shows normalized to all the searches, so it doesn't show relative search volume, it shows just normalized to all the searches, how often a term is used. You notice additive manufacturing is the technical term of 3D printing is kind of flat. The term that has been associated with the consumer's market for 3D printing has shot through the roof. And at the last Consumer Electronics Show, which was about a week or so ago, it was all of the rage. 3D printing was everywhere. The other side of it, though, was the input side. The scanning side was all the rage. Kind of not as public, perhaps, as 3D printing yet, but the input side was big there. How big was it? In 2013, there were 6 3D printing companies at CES. This year they had 30, and they couldn't put any more. They had companies that were doubling up in the pavilion that they had. And again, the question is, why? You know, here's that chart that I just showed you, and here's the stock performance of most of the major 3D printing companies in the United States. If you notice, there is a pretty good correlation between this chart and that chart. I mean, it's kind of shocking. And it's not because all of a sudden 500,000% more printers were sold into the industrial market. It's because of the opportunity in the consumer and the hobbyist market. That's, I mean, it's an important takeaway, that this run-up is not based on the fundamentals of the existing 3D printing market. It's based on the potential of doing other things with 3D printers. So why? So let's talk about that. The words are less important. You guys will get a copy of the presentation. The words are really just there that you can look at later. Why? It's changed because the input side has changed. In other words, 3-4 years ago, it would have cost $50,000 to $100,000 to buy an industrial scanner, a scanner that would let you make a digital copy of that object. Okay? Uses laser light to actually make a copy. Today, that same professional style scanner you could buy for probably $2,000. So on the industrial side, the inputs have completely fallen through the floor. But where it's even fallen through the floor even more is on the consumer side. So a little 30 seconds of history. Microsoft bought this company called Kinesta, an Israeli scanning company. Realized it didn't work as part of the Connect project, so they partnered with a company called PrimeSense. They came out with a Connect. They sold 25 million of them. Then they came out with a Connect 2, which is based on the Kinesta. And along the way, some guys realized that, boy, that PrimeSense thing that's in the Connect is actually a laser scanner. So you may not know this, but if you have a Connect in your house, you have it within your ability to scan objects and put it into a 3D printer. Because what it does behind the scenes is project laser light into your room, and from that you can create models. So some guys said, wow, let's hack it. This is a bunch of guys at MIT created this thing called the drill of death, which is they took a Connect and attached it to a drill, and they used it to create 3D models. Well, then at CES, a company called Occipital announced this clip onto your iPad, which is powered by PrimeSense. 3D Systems, a 3D printing company, announced a scanner based on PrimeSense technology at CES. They also OEM'd that product from Occipital. But unfortunately for all of them, PrimeSense was acquired by Apple about 6 weeks ago. Why do you think Apple bought PrimeSense? They bought them because they want to own the pipeline for 3D capture as part of various processes. So then another Belgian company, Soft Kinetic, same kind of looking device, did a deal with Sony for the PS4. What did they announce at CES? They announced a deal with Stratasys and MakerBot for a scanner based around their technology. Why would they announce that at CES? If you don't have content to print, printers don't matter. PrimeSense partnered with Intel. Intel invested in a company that PrimeSense powered. At CES, Intel announced a 3D camera which will be embedded in every one of their computers starting in the latter half of this year. So your next laptop you buy will come with a depth camera. That depth camera will allow you to scan things and make 3D models. Okay, and then for Geomagic, 3D Systems bought a bunch of software companies, partnered with PrimeSense. At last CES, we built a scanning solution. That's LL Cool J, if you can't see. We scanned him there. They partnered, 3D Systems partnered with these guys up there. This sort of incestuous group of scanners. The message I want you to take away is $200. For $200 or less, you can now buy a scanner which will allow you to print. Without this, there would be no 3D printing. There would be no consumer or maker's market for 3D printers. So the second thing, GPU compute. If you have in your computer at home, if you have a graphics card that's made in the last couple of years, you have the functional equivalent of a supercomputer under your desk. The algorithms for doing all this stuff, like taking scanner data and putting it together and make models, have been around for 30 years. It's just only high-end applications could leverage it. Today, your GPU on your desktop means that you can take that cheap scanner and actually make something actionable out of it. And, you know, the first transistor, the first microprocessor had 4,500 transistors. The architecture in the latest NVIDIA cards have 1.4 billion transistors. So basically completely changing the compute power. What else has changed? The whole makers movement. I mean, if you've never been associated with the makers movement, makers fairs, you know, this is a completely fundamental shift in 3D printing technology. Service bureaus like Shapeways and other places where you can print things, the whole community around Raspberry Pi and Arduino and robotics competitions, the last 5 years has really heated up. And the makers community has really embraced this technology. There's a great book which I would encourage you to read if you haven't yet. It's called Makers: The New Industrial Revolution. It's from a guy named Chris Anderson. He has his own robotics company, but he really lays out the case for the makers community and why that has changed things. And Minecraft. If any of you have kids, you know what Minecraft is. What also has changed is if you've got great software, if you've got a way to capture information, you need to have a tool where you can manipulate it. And so what has also changed is the software. There's now what I like to call gamified content capture software, which means making it easy to take the content you've captured and actually print it. Because again, back in that pipeline, if you can capture it but you can't do anything with it, you can't print it. So you need to have the whole pipeline. And what has changed in the last 3 years is that's changed too. So another huge change is crowdsourced design. How many of you have been to Kurke, the site Kurke? Okay, so you're in the minority. Kurke is an unbelievable site. If you've ever had an idea for, I got this great idea for this thing for my widget for my closet. I think Kurke is an online community where you can write up your idea, submit some pencil drawings, scan them in. Your idea will get voted up or down by people. Some people will make drawings, concept drawings, and if you get enough votes, they actually produce it and they start selling it.
How do you spell it?
Kurke, Q-U-I-R-K-Y.
Okay.
And I'll show a screen grab from it. Totally transforming the way things are manufactured. Totally changing the way collaborative design happens. This chart sort of I was able to use from a friend of mine at IBM who showed this is how much content is now available. 3D content is available in a service called Thingiverse, which is owned by MakerBot, and it's basically a community store of 3D content. It's exponential. Okay? It's like going through the roof. But this was the one that really got me. This is IBM. What does IBM say? IBM says 80% of consumers told us that we will help you design your stuff. And this is an IBM VP saying, you better accept our help, or they're just going to go on Kickstarter and do it themselves. That is a fundamental change. If IBM is saying corporately that you need to think differently about the collaborative way people are working now, I mean, it better illustrates the point than I ever could. And then here's a screenshot from Kurke. Doesn't really show much here, but you can see some of the ideas down here. These are ideas which got voted up by folks and then got produced by Kurke. So it takes money, and there's lots of it flowing into this space. So tons of money coming into the 3D capture and 3D printing space. You've got crowdfunded stuff like on Kickstarter, and you've got venture capital money coming in. Here's two pretty recent examples on Kickstarter. The first one is this Structure.io thing. Remember that clip-on iPad attachment I showed you? They raised $1.3 million in Kickstarter. Before that, they raised $8 million from a group of venture capitalists. This is a current 3D printer, which is on Kickstarter. It's a resin-based 3D printer. It's already up to $500,000. The first resin-based printer on there was made by a company called Formlabs. They raised $2 million. They just took $20 million from Draper from DFJ. This changes, I mean, both ends of the equation. You can't print if you don't have content, and the money is flowing into the space. So that just further accelerates the space. And then finally, there's always got to be some cold water thrown into this. One area of cold water is overarching policy concerns. Intellectual property issues around 3D printing is going to be a growing problem. You know, I call it the perfect storm. You know, you've got all that data coming in cheap, you've got all this stuff being printed, and right at the middle is, do you own the thing you just took a scan of? I mean, do you? Are you allowed to do it? Are you allowed to print it? Are you allowed to make a copy of it? This is exactly like the music industry 10 years ago. Exactly. And the same issues that happened there. Content creators tried to lock it down, and people pirated it, and then it's the same issues. I think we're a couple of years away because there's just not enough content yet, but I think it represents opportunities for companies to come up with forward-thinking solutions to the problem. Because the problem exists, particularly for enterprise users. So, those are the sort of key trends as I see them in 3D printing. So how do we bring it all together? Plug the.
I did.
Let's play this. So what I'm going to show you here is a quick little video of how these technologies actually come together and how you can use a cheap $200 scanner to make a model.
It doesn't take